Most people throw away an LED bulb the moment it stops turning on, but before doing that, it's worth checking what actually failed inside. This one started flickering while I was working, then suddenly died completely. Hi, I'm Dan. Welcome back to Dan Fix. So today, let's take it apart and see if the problem is easier to fix than it looks. First, I need to make sure the problem is actually inside the bulb and not somewhere else. So I grab another LED bulb and test it in the same socket. The second bulb turns on immediately without any flickering at all. Now we already know the socket and the power supply are working normally. But when the damaged bulb goes back and absolutely nothing happens, that means the failure is definitely somewhere inside this bulb itself. Now the real investigation begins. I take a utility knife and slowly slide the blade into the small gap around the plastic cover. The movement has to stay slow and controlled because most LED bulbs are sealed tightly with glue. Now the blade carefully follows the edge while the adhesive slowly begins separating little by little. And honestly, this stage matters more than most people think. If too much force is used here, the plastic diffuser can crack very easily. Then the LED board gets lifted out gently. Now I use cutting pliers to remove the wires connected to the board. But notice something important here. The cuts are made very close to the LED board itself. That leaves the wires from the bulb base longer, so reconnecting everything later becomes much easier. Small details like this save a lot of frustration during reassembly. Now, the old wire ends remaining inside the connector get pulled out completely. At this point, the LED board is finally free for testing. But before we can diagnose anything, I need a way to test the tiny LEDs individually. So now we start building a simple homemade tester. Here I have a regular paper clip. Using pliers, the metal frame gets straightened completely into one long wire. Then both ends are sharpened carefully using a metal file. Tiny sharp probe tips make it much easier to contact very small LED terminals accurately. After shaping the metal, I cut it into 2 equal pieces. Now we already have 2 thin metal probes ready to use. Next, I grab an old 5-volt 2-amp phone charger. Instead of throwing it away, we can reuse it as a low-voltage LED testing power supply. And honestly, low voltage matters a lot here because it's much safer when working with small electronic components. Now I carefully strip away the outer insulation from the charging cable. This part needs patience because phone charger wires are extremely thin and easy to break accidentally. Now I use a lighter to burn away the final insulation coating from the tiny wire ends. But honestly, using pliers or a proper wire stripper is safer because the flame can easily burn your fingers if you move too quickly. Once both copper wires are exposed, the homemade tester starts coming together. So now I slide heat shrink tubing over the joints. Heat shrink tubing acts like protective insulation. Once heated, it tightens around the wire connection, helping prevent shorts-loose movement and accidental contact between exposed metal parts. After heating the tubing carefully, the connections immediately become cleaner and much safer. But I still want the probes longer and easier to control during testing. So now I use a pair of tweezers and secure the metal probes alongside them using more heat shrink tubing. And honestly, this small modification makes a huge difference. Now the tester feels much more stable and precise in the hand. At this point, the homemade LED tester is finally complete. The USB plug goes into the charger. Then power gets connected. And just like that, we now have a very simple but surprisingly effective LED testing tool made from old parts most people would normally throw away. Now comes the most important stage. The LED board contains dozens of tiny LEDs connected together. And here's the interesting part. In many LED bulbs, the LEDs are connected in series. That means a single failed LED can interrupt the entire circuit and shut down the whole bulb completely. Finally, I found the problem. The LED marked D11 no longer lights up at all. That tiny component is enough to kill the entire bulb. Now the board gets clamped down securely so it doesn't move during repair. Then I use heat from a lighter to soften the solder holding the damaged LED in place. As the solder melts, the failed LED lifts away from the board. But now we need a replacement. So I grab an old LED board from another damaged light. Again, the homemade tester gets used to checking which LEDs still work properly. And luckily, several of them still light up perfectly. Now heat gets applied carefully to melt the solder underneath one of the good LEDs. Using tweezers, the replacement LED lifts cleanly away from the old board. Now, the replacement LED gets positioned carefully onto the correct location where D11 used to sit. This step requires patience because LED polarity and alignment matter a lot. Once everything sits correctly, the solder melts again and locks the replacement LED into place. Now the repair is finally complete. Next, the entire LED board gets cleaned carefully. Dust, old glue residue, and dirt are wiped away so the surface looks much cleaner again. Then I test the replacement LED one more time before reconnecting everything permanently. And now the repaired LED lights up perfectly together with the rest of the board. That means the repair actually worked. Now we reconnect the wires from the bulb base back onto the LED board using pliers. The longer wires we intentionally saved earlier make this step much easier now. After reconnecting everything, the LED board fits back into the bulb housing again. Now comes the moment of truth. The bulb goes back into the 220-volt socket, power gets switched on, and instantly every single small LED lights up again. So, what do you think about this repair method, and where are you watching from today? I'd really like to learn what repair tricks people use in different places around the world. If you enjoyed this project, don't forget to like and subscribe because there are still many more useful DIY repair ideas coming soon. Thanks for watching, and I'll see you in the next video.